Today's video is about the importance of renal clearance test. In order for the body to function properly, it needs a way to get rid of toxins and other waste materials. That's where the kidneys come in. Their main function is to filter the blood and remove any unwanted substances from the body. The concept of clearance. Renal clearance of a substance is the volume of plasma that is completely cleared of a substance by the kidney per unit time. Renal clearance gives an indication of the functioning of the kidneys, such as rate of glomerular filtration, rate of blood flow, assessing severity of renal damage, tubular reabsorption and tubular secretion of different substances. Significance of clearance. The significance of clearance tests is the measurement of glomerular filtration rate. Glomerular filtration rate is the volume of fluid filtered from the glomerular capillaries into the Bowman's capsule per unit time. Principle. Glomerular filtration rate is equal to the clearance rate when any solution is freely filtered and is neither reabsorbed nor secreted by the kidneys. A substance that is completely filtered but neither reabsorbed nor secreted should be used to measure glomerular filtration rate. INULIN is the ideal substance used to measure glomerular filtration rate. It is completely filtered and neither reabsorbed nor secreted. So, INULIN clearance indicates glomerular filtration rate. Renal clearance tests. These tests are done to assess the functions of different parts of nephrons. Renal clearance of a substance is the volume of plasma that is completely cleared of a substance by the kidneys per unit time. It is calculated from the following formula: C equal to U multiplied by V divided by P, where C is the clearance, U is the concentration of the substance in urine, V is the volume of urine excreted per unit time, and P is concentration of the substance in blood. As an example, let's say that in a 24-hour period a man has 2 liters of urine, and his plasma sodium concentration is 145 milliequivalent per liter, whereas his urine sodium concentration is 190 milliequivalent per liter. Using this information, let's calculate his renal clearance for sodium. First, we need to calculate his urine flow rate, which is the urine volume divided by time. That is 2000 milliliter divided by 1440 minute, which is 1.39 milliliter per minute. Since urine concentration is 190 milliequivalent per liter, we multiply that by 1.39 milliliter per minute and divide by the plasma concentration 145 milliequivalent per liter, which is equal to 1.82 milliliter per minute. So that means that 1.82 milliliter of plasma is cleared of sodium per minute. Types of clearance tests. Clearance tests are divided into endogenous and exogenous tests. Endogenous tests include creatinine, urea and uric acid clearance, whereas exogenous clearance includes INULIN, para-aminohippuric acid and Diodrast clearance. Endogenous clearance tests. Creatinine clearance. It is the amount of creatinine excreted in urine over 24 hours. The most common method to measure glomerular filtration rate in clinical practice is to determine the 24-hour endogenous creatinine clearance. It reveals how much creatinine is circulating in blood. Rate of production and excretion is steady, but increase in the expected range can be considered as reliable indicator of renal impairment. Its determination does not require administration of exogenous creatinine, as creatinine is a product of muscle metabolism. Clearance is often measured as milliliters per minute or milliliters per second. Normal values are 97 to 137 milliliter per minute in males and 88 to 128 milliliter per minute in females. High creatinine level causes acute and chronic kidney disease, ureter obstruction, dehydration, and glomerulonephritis. So, how do you calculate 24-hour creatinine clearance? Creatinine clearance specimens required are 24-hour urine specimen and plasma or serum creatinine collected during the urine collection. To calculate creatinine clearance, the creatinine level in the urine is multiplied by the total volume of urine produced over 24 hours. This is then divided by the amount of creatinine in the blood. The final value is converted to milliliters of blood per minute. However, some creatinine is reabsorbed by the tubules and some may be secreted. So, when precise measurement of glomerular filtration rate is required, INULIN clearance is preferred. Uric clearance. The blood-urea clearance is defined as the volume of blood cleared of urea per minute by the kidneys, or in other words, the volume of blood whose urea content is represented by the urea excreted per minute in the urine. Normal values range from 12 to 20 grams per 24 hours. High blood urea level causes kidney disease or failure, fever or infection, dehydration and poor circulation. How do you calculate 24-hour blood urea clearance? Blood urea clearance specimens required are 24-hour urine specimen and plasma or serum blood urea collected during the urine collection. To calculate blood urea clearance, the blood urea level in the urine is multiplied by the total volume of urine produced over 24 hours. This is then divided by the amount of blood urea in the blood. The final value is converted to milliliters of blood per minute. Uric acid clearance. This test measures the amount of uric acid in your blood or urine. Uric acid is a normal waste product that's made when the body breaks down chemicals called purines. Purines are substances found in your own cells and also in some foods. Uric acid measurements are used in the diagnosis and treatment of numerous renal and metabolic disorders. High uric acid level causes hyperuricemia and hypouricemia. A buildup of uric acid can cause problems such as gout, kidney stones, and diabetes. Normal uric acid range. A healthy uric acid level typically ranges from 2.5 to 7 mg per dl in males and 1.5 to 6 mg per dl in females. How do you calculate 24-hour uric acid clearance? Uric acid clearance specimens required are 24-hour urine specimen and plasma or serum blood uric acid collected during the urine collection. The formula of clearance of uric acid is urinary uric acid concentration multiplied by 24-hour urine volume divided by serum uric acid expressed in milliliter per minute. Glomerular filtration load of uric acid was calculated as clearance of uric acid multiplied by serum uric acid and is expressed in micromole per minute. Exogenous clearance tests. INULIN clearance. INULIN is a polysaccharide of fructose. It is neither reabsorbed nor secreted by the tubules. INULIN clearance is used as an indicator of plasma clearance mechanism. A comparison of the clearance of a given substance with the clearance of INULIN provides information about the renal mechanisms used to remove the substances from plasma. A large initial dose of INULIN is injected intravenously into the body. To maintain a relatively constant arterial plasma level, INULIN is infused at a constant rate into the body. After some time, concentration of INULIN in plasma in venous blood, urinary concentration, and volume of urine excreted per minute are determined. INULIN clearance is equal to urinary concentration of INULIN multiplied by volume of urine excreted per minute divided by concentration of INULIN in plasma. Urinary INULIN clearance is considered the gold standard for measuring glomerular filtration rate because INULIN has all the properties of an ideal marker. It is freely filtered by the glomerulus, is not secreted or reabsorbed in the tubules, and is not synthesized or metabolized by the kidney. The only way that INULIN gets into the urine is by filtration. Thus, the volume of urine cleared of INULIN is the same as the volume that was filtered. In other words, the clearance of INULIN is the glomerular filtration rate. The filtered fraction, which is how much fluid is reaching the kidneys and passes into the renal tubules, is the same for INULIN as it is for plasma. So we can use it to get an accurate estimation of how much fluid is filtered from the renal glomerular capillaries into the filtrate, also known as the glomerular filtration rate. When we compare the clearance of substance X to INULIN, we get something called the clearance ratio. This can be calculated simply as the clearance of substance X divided by the clearance of INULIN. If the ratio equals 1, then substance X is the same as INULIN and must also be freely filtered and not actively secreted. If the ratio is greater than 1, the clearance of substance X must be greater than INULIN, and that means that it must be freely filtered and also actively secreted by the kidneys. If the ratio is less than 1, then the clearance of substance X must be less than INULIN, and that means that it must not be freely filtered, like with albumin, or it may be freely filtered but then some of it may be getting reabsorbed by the kidney, like with glucose. For example, let INULIN clearance equals 194.6 ml per minute and sodium clearance equals 1.82 ml per minute. Then the clearance ratio for sodium is 1.82 ml per minute divided by 194.6 ml per minute, which is 0.009. PAH clearance. PAH clearance is used for the measurement of renal plasma flow. To measure renal plasma flow, a substance, which is filtered and secreted but not reabsorbed, should be used. Such a substance is para-aminohippuric acid. A known amount of PAH is injected into the body. After some time, the concentration of PAH in plasma and urine and the volume of urine excreted are estimated. Since PAH is completely cleared from the plasma, the clearance rate of that substance is equal to the total renal plasma flow. How do you calculate 24-hour PAH clearance? PAH clearance test requires 24-hour urine specimen and plasma or serum PAH collected during the urine collection. To calculate PAH clearance, the PAH level in the urine is multiplied by the total volume of urine produced over 24 hours. This is then divided by the amount of PAH in the blood. The final value is converted to milliliters of blood per minute. Diodrast clearance. Diodrast is a substance which is excreted through the kidneys by tubular secretion. At low plasma concentrations, diodrast is practically completely removed from the renal arterial blood in one circulation through the kidneys, and consequently, diodrast clearance can be taken as a measure for renal plasma flow. To conclude, renal clearance of a substance refers to how quickly a particular substance is removed from the plasma by the kidney and excreted in urine. So something with a high renal clearance means that it will be quickly removed from the blood, and vice versa. If the urine concentration is high but the plasma concentration is low, then that must mean that a lot of the substance was removed from the blood, leading to a high renal clearance. By comparing this rate to the clearance rate of INULIN, which is freely filtered and not secreted, we can get an idea of if the substance is secreted, reabsorbed, or poorly filtered. Renal clearance gives an indication of the proper functioning of the kidneys.